right, and welcome to Absolute Value Transformations Level 4. Now, in these sets of examples, we're going to include all all four different types of transformations that we've talked about thus far. So let's talk about f of x to g of x. Now, notice that my formula for the vertex form is a absolute value x minus h, close the absolute value bars, plus k. And let's go ahead and see what things we have over here. We see that our a value is equal to 1/2. We see that here we have, in our grouping, we have this whole x plus 3. So wait a second. We know that we want to set our grouping equal to 0. And lastly, we have our k value. Okay, let's go ahead and solve for our h value first. So we can minus 3 from both sides. And we get x equals -3, or aka h is equal to -3. All right, h is equal to -3. And of course, k is equal to 5. All right, so let's go ahead and talk about our rules. We know that when a falls in between 0 and 1, which is what 1/2 is, well, we know that we have a vertical compression. Remember, if this a term had been greater than 1, we'd have a vertical stretch. For our h value, we see h is -3, so this is going to translate us 3 units left, okay? And here we have a k value of +5, so we know that this will translate us 5 units up. Okay, so let's go ahead and start off by just graphing our parent function. We know they'll just look something like this. Okay, now let's go ahead and work through this next one. Now, one thing to note here is when your h value, so remember our vertex is at h comma k, and so what we can say is that our vertex is at -3 comma 5, and I'll graph it in orange. So we're going to go to the left 1, 2, 3, and up 1, 2, 3, 4, 5. And here, since our slope is 1/2, we know we're going to go up 1 and to the right 2, and then up 1 and to the right 2 again, and we have this very wide graph. Okie doke. All right, let's go ahead and move on to our last example. Okay, here we have example 7, and we have a lot going on here. So let's go ahead and note some things. Here, our a term is negative, and when you think about 5/2, is that, let's see, is that in between 0 and 1, or is it greater than 1? And we should recognize that, in fact, a is greater than 1. The next thing that we want to note is here, where our grouping is x plus 2, we want that to equal to 0. So we can say, okay, you know what? X plus 2 is equal to 0. We would subtract 2 from both sides and say, you know what, our x value is equal to -2, or aka our h value is equal to -2. And the last thing would say, hey, over here on the outside we have our k value, where k is clearly equal to 3. All right, let's go ahead and write out our vertex form. We have f of x is equal to a absolute value x minus h, close absolute value, plus k. Now let's see what things we see. We see that, let's see, we have when a is equal to -5/2, for a negative a, we have to reflect over the x-axis. And when a is greater than 1, remember we have a vertical stretch. Okay. And then lastly, what can we say about our vertex? Well, we know that our h value is -2. We know that our k value is +3. Remember, your vertex is always at h comma k. And what's that really telling us? Well, the h value is telling us that we are translating 2 units left, and our k value is telling us that we are translating 3 units up. All right, so let's kind of talk it out. if our vertex is at -2 comma 3, we'll go to the left 2 and up 1, 2, 3. Let me go ahead and do this in nice blue. And then we see that our slope is really like saying -5/2. Well, that means that we're going to go down 1, 2, 3, 4, 5. So we'll go down 5 and then to the right 1, 2. That actually puts us here. And we can just go ahead and draw our V-shaped graph. Now the last thing we want to do, which I usually do first, is let's just go ahead and see what our parent function would look like. It's always at the origin. You go up 1, right 1, you get your first point. And there we go. There's our parent function versus our function g of x. All right, I hope this was helpful, and I'll catch you guys in our next video series.